All right, so let's actually graph a few of these here. So here we're given f of x equals 1/3 x squared. Now remember that we can do this a couple different ways. We can start with the parent function and we can understand what the transformation is happening here, and we can kind of plot it that way. We can also make a table of points and we can plot it that way, and just plot the points and then kind of trace through the graph, kind of understanding it's going to be a parabola, and it's symmetrical about the axis of symmetry and all those things, right? So there's a few different ways we can do this. We can also, try to get it in vertex form and do that type of thing. And we'll talk a little bit more about that later. But let's make a table of values on this one just to kind of get a sense, and then we'll compare it with the original and maybe talk about how to graph it that way. All right, so here you can see if we plug in 0, you get out 0, right? If I put 0 in here for x, right, or here, then you can see it's going to be 1/3 times 0 squared. 0 squared is 0 times 1/3. That whole thing's going to turn to 0, right? If I put in 1, then it's going to be 1/3 times 1 squared, right? And that would just give me 1/3, because 1 squared is 1, and 1/3 times 1 is 1/3. Okay, if I plugged in 2, all right, so if we plugged in 2, we would get 1/3 times 2 squared, which is 1/3 times 4, or 4 over 1, and so that would end up being 4/3, okay? And so forth in that direction. All right, and then if we plugged in, let's just plug in a negative just to see what happens. Let's plug in -1. And if we plugged in -1, if we squared -1, we get +1, right? So it's just 1/3 times +1, which is 1/3. And here where you can see the symmetry come in, right? If we plug in the opposite of 1, we get the same output, right? Remember, that's if you plug in f of -x and you get f of x, the same as f of x, that's symmetrical about the y-axis. So that's what's happening here, right? So if I plugged in -2, we would get positive 4/3, right? The same as what we did if we plugged in +2, right? If we plugged in -3, what do you think we would get? Good. If you said 3, you're exactly right, right? Because when we square -3, it's the same as squaring +3, and so our outcome will be the same as if we plugged in +3. So now let's plot these points. So we have 0, 0. We have 0, 1/3. We have 1, 1/3. We have 2, 4/3. So that's going to be like right about here. Okay, and then we have 3, 3. All right, so you can see the trend there. We can kind of continue this out. So it's going to be something like that, right? Now, if since we didn't move left or right, we know that it's the axis of symmetry is going to be the y-axis, and so we could, without plotting some of these negative points, we could just plot the mirror images right there, and right there, right, and then just graph the other side as a mirror image. Okay, but we actually found those points too, right? Once we did the -1, we realized that they're going to be opposites, or that they're going to be the opposites inputs produce the same outputs, and so we could just graph that way too. So you can kind of use symmetry to graph, or you can kind of use your transformations, or you can plot some points, or you can kind of use combinations of those. Now the axis of symmetry, which is always good to note in a parabola, is going to be x equals 0, right? So x equals 0 is the equation of the y-axis, right? It's the vertical line that goes through the y-axis. So that's our axis of symmetry, and you can label that with AOS, the abbreviation there. Okay. All right. So that's our graph. Since when you don't see any pluses or minuses, that means your vertex is 0, 0. Okay. If you don't see any pluses or minuses, that means it didn't shift, and so that means your vertex is going to stay right on the origin. Okay. And that means your axis of symmetry is going to be x equals 0 as well. All right, so here's another one, f of x equals 2x squared, and I did some of the work to make a table just because I know y'all can do the math, so I don't want to spend a whole lot of time showing you that like question by question, but you can see this is what happens when I input 0, 1, 2, 3, etc., right? And you can see 0, 0 input gets an output of 0 as well. Since there's no pluses or minuses, same thing. This ends up being our vertex. And then if we plug in 1, we get 2. If we plug in 2, we get 8. If we plug in 3, we get 18. If we plug in -1, we see that we end up getting the same thing as if we plug in +1. So again, that means it's symmetrical about the y-axis. And so then I was able to say, okay, well, if I plug in -2, I'm going to get +8, right? And then what do you think if I plug in -3, what do we get? Good. If you said 18, you're exactly right. It's going to be the same as what happens when we plug in +3. Good. So if we're to plot these points, we get something like this, and you can see it's a little off the chart here because it's a vertical stretch, right? This time by a factor of 2. I forgot to compare the last one to the original function, but the original one goes through, the parent function goes through 1, 1, and then 2, 4, right? It's squares, so 3, 9, and so forth, right? So the original one kind of looks like that. And this one you can see is narrower because we stretched it vertically because of this 2. Since 2 is positive, it's still facing upward, right? Like the last one as well. And so, yeah, so that's what it is. Just to compare the last one to the parent function, remember the parent function goes through 1, 1, and then 2, 4, etc., right? So it's going to look kind of like this. And then it'll go through like this. So you can see that's, this one is a vertical compression by a factor of 1/3. So you can just kind of see the difference there. All right, and back to this one, our axis of symmetry is same thing, x equals 0, right? Goes through the, or on the y-axis, so there's our axis of symmetry. And then since we don't have any pluses or minuses there, our vertex is going to be 0, 0, right? So h and k are invisible in this case.